Cowabunga, dudes and dudettes. You all ready for part 2? Let's hit it!
Teenage Mutant Ninja Turtles, Teenage Mutant Ninja Turtles, Teenage Mutant Ninja Turtles, heroes in the half shell. Let's kick some
How's it going, everyone? Alex here. Hopefully you liked that intro. I had a little bit of fun with it. But we're going to be jumping right into our project. We got a lot to do, so no time to waste. So here we are, back where we had left off in the last video. Due to the hardware loss that I had suffered in November, I had to rebuild this project. So there's going to be a bit of a transition here. And rest assured, the code's all the same, but visually it's going to be just a little bit different. So let's transition to that. All right, and just like the classics, we are out of black and white and into full-blown color. So as we can see here, our movement's all still the same. All I've done is import some sprites here from the Shredder's Revenge game. I was able to get some of those off of line. I did not make them, so I do not own the rights to them. I'm just using them for this template. Please go gentle. Don't sue me. Whoever owns Turtles Nickelodeon, don't sue me. As you can see over here on the sides, there's not really a whole lot more going on. I've went ahead and added a little bit more sprites. This is the default Donnie sprites. I have jump, roll, and fall, as well as walk and idle. The other thing that I've decided to do is build the background of our level using our collision cubes. So all this is collision objects that have been rotated and stretched to fit the flow of our game. Other than these changes, the only thing I've made is some little adjustments here in the event sheet section. As you can see, this is mostly just organization. I haven't actually changed anything from that original code. So rest assured, I haven't skipped ahead. I've just changed up the art a little bit. All right, now we're going to talk about finite state machines, or rather the player state machine. This is a mechanic that navigates through idle, jump, attack, and other transitions we might need for our character. I don't want to bore you with technical detail, and I'll have a video on finite state machines here pretty soon, but just to summarize it, a finite state machine controls your object or player from being able to do actions that we don't want them to do, like dashing while in the air or potentially sliding while in the air. We need to be able to restrict our player from only being able to do actions when we want them to. So to do that, we have to start by adding a state component to the object player collision. We're going to be going to variables, and we're going to be creating a new variable. And this one's going to be called state. Now, state is actually going to be, normally it's a text that we want to start in, but we're using a dual state machine, which is a little bit more of a complicated thing. But essentially, we need to use a structure and add two different children. One of them is for the object, which is what we're currently working with. So object, and we'll do the object text, and for the object we're going to do init, or initialize, capital I and then NIT. And then for object number 2 we're going to do sprite, and we're going to start our sprite off with the idle state and make sure we also make that a text, and capital I on idle. So we have state object and state sprite. So if I hit OK, and that's because we have a player sprite and the collision box. Because we have to use both top-down and side-scroller mechanics to be able to move our beat-em-up character the way that we want them to, we have to kind of build this machine this way. So that actually won't currently do anything because, well, it's not connected, right? So now that we have the variable in place and we have the foundations of our script, we need to start the finite state machine, and we're going to be using external events for this. The player finite state machine is only specific to the player. So we're going to start with creating a new external event, and we're going to call it temp finite state machine. So temp FSM. Now we're going to open into that. It's going to ask you what scene you want to load from, And this is important because if we don't load from the right game scene, we won't be able to access all of our objects. Thankfully, we only have the one. Well, you only have the one, I have two, but we'll be selecting our game scene. So the best way that I can explain this in Gdevelop terms is that effectively we have 3 event groups. So we're going to make those event groups. We're going to create event group and we're going to copy and paste it 3 times. Each one can have a event if you want in it. And effectively the way that this works is on load of script. So we're going to call this one on load. This one is during runtime of script. So we'll call this one on run, or during run, actually. It's kind of a better way of explaining it. And this one is the transition or the exit script. Think of these as independent boxes. This is the start of the script, this is the end of the script, and this is everything that runs in the middle of it. This is all the information we need to process player inputs or anything we want this script to do. Let me show you how this works. We're going to duplicate the finite state machine. Right click on it, duplicate, and then we're going to start the turtle finite state machine. So the next step here is to add a new external event. We're going to call this the turtle finite state machine. And this is less a finite state machine as it is the manager of the finite state machine. We want to be able to choose our game scene as the external event so we can access all of our objects. And then what we're going to do is start building the directory of all the other scripts that are going to be managed inside of the finite state machine manager. So the first thing I want to do is jump over here to our game events, and I want to pull out the player collision. All we're going to do is cut that out. So you can right click on it and do cut. You can copy it, but make sure you delete it afterwards. And then we're going to put it as the first event inside of our finite state machine. We're going to be organizing all of our rule sets for the turtles or the player inside of the turtle finite state machine. So now is when those variables that we recently created come into play. We're going to create a new event. We're going to make an event group. We're going to call this states. So the first condition we need to run is targeting the object player collision. And we're going to type variable, select the variable, and then we're going to be choosing state.object because this is the player object and the player sprite state. We're going to be setting this to initialize. Go ahead and hit OK. If the variable state.object of this object equals initialize, so if the variable of text reads as initialize, we're going to be deploying our initialize state. Well, currently we don't have that, right? So we need to make it. So this is how this works. Underneath this, we're going to do Shift D to create a child node. We're going to right click, add new event group. We're going to call this state node. So what happens is when this object equals initialize, we're going to initialize the finite state machine for initialize, right? For init. So currently we don't have it. So what we need to do is come down to here, duplicate our temporary finite state machine. We're going to call this one turtle finite state machine underscore init, as in initialize. We're going to open that up. And now we're going to set up the initialization script. This happens to be the easiest script to set up because there aren't any onload or runtime code that we need to do. Basically, this is a failsafe to make sure that we're properly transitioning into our game state. So now if our turtle starts in the initialized state, we need to adjust our exit script to make sure that we can load into another state. So we're always going to have this be triggering. So the second we load into this, it'll keep trying until it works. And then we're going to change the object player collider variable. And we're going to change object state object equal to, and now it's going to be idle. So this creates the dynamic loop that we need to be able to come back and forth between our game states. So follow along here, just to make sure you understand. The player object contains the variable of the object state. The object state currently is initialize. Automatically, when we start the game, object will be set to initialize. You can click on it here on the game scene, and then go to its object properties. We can see that it has these variables applied to it. So if we want our finite state machine to be started and make sure it works, we have to go to our game scene events, and we need to run code that lets it know it's time to connect this script. So to do that, we right click, add, and we're going to be linking an external event. We're going to be linking the turtle finite state machine. Because the game scene events are tied to the game scene itself, every time this runs, it'll be checking and including files from this location. So no matter what happens now, the turtle finite state machine starts, so we can follow the trail. So here, initialize is true. Here, the events are running. And then inside of the events, we're checking if the state is initialize. And if that's true, and just like we did in the game events, we now need to right click, make sure we do it over here on the corner, add, and then external events. We can delete this other condition because we don't need it. And then we're going to be checking and running the initialize step. So essentially, now the loop is, it goes from our player and checks our game scene. It includes the turtle finite state machine, and this is the manager. So for each state we have, we're going to want to continue down all of this. So just to make this extra clear, we're going to add another event group. We're going to call this one init state. Make sure it's dragged underneath. And then we're going to duplicate this and call this one the idle state. And just like everything else, we need to make sure we type it correctly. And now we don't currently have an idle script. That's okay. We'll be building it in just a moment. We're going to go back to our initializer. So because this is true, we now deploy this code. But as soon as this deploys, it's automatically going to set us into idle. So we can validate that this is actually happening. One, by checking our player in the debugger, but also we can just use the debug tool. We're going to log a message to the console, and we're going to log to idle. So the log message is to idle, and this is the finite state machine group of messages. We can hit OK. And now when we run the game with the debugger on, we can minimize this, close this out, and we can see right here that it logged. So it went to the idle function. So as soon as the variable changes to idle, we unload this document. Basically, essentially, it gets closed, and we go back to the finite state machine, because now this variable is now set to idle. So we need to then build the idle state. We'll go back up here, right-click on finite state machine, duplicate, turtle, finite state machine, and then idle. We can see that that's been appropriately connected. We can launch that open. And now we need to set our idle script. These scripts don't just deploy one time. So every time we transition to idle, say from jump or move, then we need to redeploy some script here. So what's common practice is to set our animations here on load. So the first thing we do is add a trigger once, because every time we load into this, we want it to happen. And what do we want to happen? Well, we want the player idle sprite, so the player sprite animation, and we're going to be doing animation by name. If it does not equal idle, and so basically every time we load into the idle script, if our animation isn't idle currently, then we need to change it to idle. So it's player sprite animation by name, and set it to idle. And since we're passing this idle animation into the player sprite, right? We're setting it to idle. We should also keep everything consistent and target our player collider, do variable or var, and then select the state.sprite. And now set this to idle. So hopefully this is starting to connect some dots in your head. Every time we make an adjustment to one part of our character, we need to update our current state to keep everything nice and tidy. Well, in idle, we actually don't have any runtime scripts. So when we idle, we don't actually do anything, right? This is what happens while we're idling. So you could add some complex animation changes. Maybe your character has his foot tapping like Sonic the Hedgehog when you wait too long or something. So that is something you could do here in the runtime, but we're not going to be doing that. Instead, we're going to be looking for transitions. This is what happens whenever we press a button or enter a key. We want it to leave this state. These are the trigger effects. So one of the things that we can do to leave our transition is to move. So we want to be looking for any of our movement keys. Well, currently we don't have any of them mapped. So to show you how to do key mapping, I'm going to go up here to the project manager and go to global variables. Inside of our global variables, we're going to add a new variable, and it's going to be a structure. We're going to call this key bindings. We're going to add some key bindings. So we're going to add some children. We need up, down, left, and right. And we also need jump for now. Oops, I accidentally didn't make that as a child. And now we can add jump. And because these are keyboard keys that we're key binding, we need to change all these to text. And we need to decide what keys we're going to be using. For this current build, I'm going to be using WASD. And we're also going to be setting up controllers at the same time. So for down, we need to do lowercase s. For left, A, right, D, up, W, and then for jump, it's space with a capital S. If we're targeting controller buttons, they're capitalized, and keyboard bindings are generally lowercase unless they're a special key, like shift or left control, right control, and so on. So we're going to hit apply, and if you don't already have the extension installed, install the gamepads extension now. Just go to your extensions and, well, it's right there. So there you go. So just grab that extension and install it. And now we're going to set up our input key. So we're going to be adding a OR statement first, because we're going to be checking for two different button impresses. We're going to be checking first for key, and then we're going to be using the key pressed expression. We're going to hit OK. And what we're looking for is we're going to type key bindings, and we're going to be looking for the up, left, down, and right keys being pressed. So if we're going to copy and paste each of these, we're going to do up, we'll do down, do it 2 more times, right, and left. So if any of these keys are pressed, if any of them are pressed, we know that we're going to be moving. Our character is going to be moving, not jumping. This is a different, this would be different. Jumping needs to be in its own section. But for this one, we can now add a controller input as well. So we're going to go add subcondition, other conditions, gamepad controllers, and we're going to be looking to see if a game stick is being pushed. We're going to be looking for gamepad number 1, the left stick in any direction. Hit OK. And now, simply speaking, as soon as we hit one of these keys, it will trigger whatever our action is. And what we want to do is change our action of our object. So I'm going to copy this one, change sprite to object, and then change the state object to move, because that's going to be our walking, running finite state machine, right? So moving is the only thing that we can do currently to leave our game state. Well, I also know that we're going to want to do jumping, so I'm going to prepare ahead, and we're just going to copy and paste this. We're going to delete all of this except for these two. And instead of looking for the key binding for down, we're going to be looking for jump. And we're going to go back to our controller settings. You can do that by double clicking. And then we're going to be looking for a button pressed. And we're still checking the first gamepad. And we're going to be looking for the Y button. Now you may want it A or X or something else, but I'll be assigning it to Y. And so now, if jump key or Y is pressed, we're going to move the object into the jump state. If any of the movement keys are pressed, or the joystick left is pressed, we're going to be going to the move state.
Okay, so I went ahead and just added the event groups to move, and then put the move script underneath it, and then to jump, just to make it a little bit more visual. Let's go ahead and go back to our project manager, right click on idle, and we're going to duplicate the idle script this time. We're going to change idle to move, and then we're going to double click on it to enter it. Per usual, we're going to start at the top where we load our node in, and instead of idle, we're going to be changing this to walk, and we're going to do that with all of them. Now, we're going to start by creating each of the movements one at a time. So we'll start by moving key bindings up and duplicating it. We'll swap them out with up, down, left, and right. Be sure to delete the up binding. And then we're going to move the stick bind into each of them as well. And so it'll actually kind of look like this. Copy it and paste it 4 times. And then we're going to do what we just did a moment ago and redelete the up bindings and replace them with the correct direction. We can delete those extra conditions now. And then what we're going to do is change the direction. So this one will be up, down, left, and right. So now the action that we want to do is for the player object, collider. So we can click on that, and then we're going to simulate the control. And again, we're going to be simulating the direction because this is the top-down movement. So we're going to do up, down, left, and right. You just double click on them. Go up, down. Simulate left key press. And simulate right key press. And then we need to finish the loop before we can run this to make sure we return back to idle. So we still want to be able to jump, but I'm going to duplicate the jump script, and we're going to now do to idle. And for this one, we're going to be checking the condition and check to see whether or not the object is moving. So if the collision sprite is moving, and we'll invert it, so is not moving, and the sprite is on the floor. So we'll do player sprite, and we'll check is on the floor. So if the collider isn't moving and the sprite's on the floor, we're going to go ahead and change back to idle. Now that it's all set, what we need to do is go back to our finite state machine, copy the idle, paste it. We're going to do it twice. We're going to change this one to move. And now we can set it to move. And then we'll set the last one to jump. And then, of course, set this one to jump as well. So if we check this, we'll be able to see that our character can move with the WASD keys. However, if we press space key, we're going to jump. But then if we press our arrow keys or our movement keys with WASD, we're not going to be able to move. In fact, actually, our arrow keys will let us move. Well, wait, what happened? If WASD doesn't work, why are our arrow keys working? Well, that's actually because Gdevelop has some built-in control systems. If we close out of this and go to our game scene, we can go to both our player collider, behaviors, and turn off the default controls for top-down movement. Hit apply. Go to your player sprite, behaviors, and do the same thing for the platformer. Now, if we were to go to our game and use WASD, we can move, and the arrow keys no longer work. But then if we try to press jump again, nothing happens, and our arrow keys or WASD aren't working. And that's because we're actually translating into a different state, and we're not able to get back to idle or move because we're stuck in the jump state. But how would we know that if I didn't tell you? As you might have noticed, I have a text up here that we're going to be using to set up as our debug text. This is going to tell us what our current player state is while we're demoing our game. So we can press X. Make sure you have a text created. If you don't, you can just add a new sprite, go down to text and set that up. We're going to change it to be called debug. And we're going to put text inside of it as our base text. If we go to our event sheet, at the beginning of the game scene, we could set the current player state here, but actually it's one of those things that needs to run all the time. So we're going to go to add action, and then we're going to click on debug, text, and we're going to pass through the object, player collision, dot, state of the object. We're going to hit OK. And now when we hit preview, we can see that we're in the idle mode, and now we're in move. When I let go of the keys, we go back to idle. But if I press jump, we're stuck. And again, that's just because we don't have a script for it. So let's go ahead and continue on our work here, and we're going to finish this up. So to make our jump script, we actually need to duplicate our move script. Let's do that now. Duplicate, and rename this to jump. So this might be a little confusing to the general structure of a finite state machine, but as we saw in idle, when we press a movement key, we move to the move section. But when we're in any other state, or if we've entered the jump state, we don't want to move to the move state while we're jumping. So we're going to first actually remove the to jump because we don't need that anymore. And then we need to recognize that we need to be able to move while we're jumping. If we were to press any key and move to the move state, it wouldn't allow us to control our fall because we'd be moving, but it wouldn't recognize us as being on the floor, and so it would get confused and wouldn't really know what to do with you. So this is why we refine what we do in each step. So in the runtime, we still want to be able to move our character, but we don't want to move to the move state. That's why it stays here. Now, as I said at the beginning of this video, I've added extra sprites, and I'm going to capitalize on that now. So I'm going to focus on adjusting our load state in the beginning, and we're going to start by checking whether or not we're jumping. Now that we've set the jump, I'm going to do something you probably haven't seen before. I'm going to be adding a timer action. We're going to start the action as soon as we enter the jump, and we're going to add a timer to our player sprite, as that's the one that's going to be rotating through the animations. So we click on player sprite, and we type timer. We're going to start or reset a timer, and we're going to call this the jump timer. We're then going to create a new action, and we're going to check that timer value. If the player sprite timer, and we're going to be looking if the jump timer is greater than or equal to 0.25 seconds, so a quarter of a second, we're going to change the animation to roll, and make sure that we change the sprite animation, the state sprite animation of the player collider to roll as well. And then we're going to do one more condition, and we're going to be checking to see if it is rolling and wait for it to stop. So we can actually go to the jump animation and copy it, paste it down here, click on it, press J to undo the not feature. If you press J, it'll say not, and then now is. So the animation of player sprite is equal to, and we don't want jump, we want roll. And when the player sprite animation, and we're going to be looking for has finished, So when the animation is finished, we're going to set our animation to fall and make sure we set the sprite descriptor inside of the player collision to also fall. And we only have a few more things that we need to do in here. We actually need to add a key. We're going to be double clicking on the key bindings and adjusting it to jump key. And here we'll also change this back to button pressed, and we'll be checking for the Y key or whatever key you bound the jump key to in the other actions, such as move. And then instead of simulating up, we're going to be simulating jump. Now, jump isn't an action that we can do on the player collider. So we're actually going to be simulating that on the player sprite. Then you're going to go down to simulate jump key press, hit OK. So for jump key, we only want the player to be able to jump once. Outside of the or condition, we need to add a trigger once. So now whenever we press one of these keys, we'll only be able to jump one time. And then once we land, we'll go through a sequence that decides what we should do next. We're going to scroll back up to our timer, and I recognize I forgot to delete the timer right here. So we need to make sure that when we start the timer, we also delete it somewhere. If not, it can never equal this again. So and also therefore not be able to stop rolling. So we're going to go into our actions, go to our timer, and now we're going to delete a timer object from the player, and the timer name is jump. In priority, we need to move up the player being on the floor as being the first check. And then we're actually going to be removing the collision check and instead checking to see whether or not buttons are being pressed. So like in move, now we're going to be checking whether we're on the floor. If the controller is not being moved in any direction, and again, that's is not, so press J. And if it's not, we're going to be setting our object to idle and the state object, or the state sprite, rather, to fall. And this will make sure that our animation sequence is doing what it's supposed to. We're going to copy this and paste it. And if we are touching the ground and we are moving in any direction, then instead of transitioning to fall, we're going to transition back into move. Now, since we added key binding control for our controllers and for keyboards, we have to add the extra keys here. So what we're going to do is hold control. So what we're going to do is hit shift and click on the right key, the left key, the down key, and the up key. We're going to hit Control C to copy them. And we're going to paste them all into our idle script. And if none of these buttons are being pressed, then this can happen. And on this one, if any of these are being pressed, this one will require a OR statement. We're going to take all of these and move it into OR. If any of these are being pressed, we're going to move to move when we're on the floor. And as long as no keys are being pressed, then we're going to go into this. So let's preview it. Use our movement keys. And now we can see our players animating. The space key to jump. And now we see we've got a little bit of a jump issue. We're going to take a look at that. We need to go back to the beginning of our events and clean this up, because we have some overlapping results. This is going to end up messing with our animation tree. And then we're going to change the player's X position using that jump collision plus 22. And then the rest of this can get deleted. I also want to add an extra action, and we're going to now hide that player collider. Let's go ahead and do that by typing hide. Hide its visibility. We can hit preview. As we jump, we'll see our roll. And as we move, we can now see our player move and our animations work. We can see that our debugger's working as it should. And that's all I have for you. So hopefully you learned something. I didn't want part 2 to be extra long, so we'll be adding some extra finite state machine mechanics in part 3 when we start working on our combat. Well, until next time, remember, happy game making, and...
I made a funny.
On the half shell, they're the heroes for in this day and age.